Yes,
Love it.
yes. Hi, everyone. Yeah, no name yet. Yeah, you can go to the next slide straight. Yeah, because basically I'm not presenting any specific software package under development, but rather a few ideas that I presented in the form that we proposed a few weeks ago. So let me mention first that I have a personal bias toward pulsating and periodic stars, such as Lyra and or kind of Cepheids and Delta Scuti. And so this drives my attention and my interest to the main pillars that I see that are independent but still very highly connected between them, which are identification of variable sources, their classification, and their characterization. And in this sense, I would like to discuss in these days all the software that can be developed that may use a multi-parametric scheme, in the sense that in my experience with analyzing light curves, it's very important not only analyzing the time series per se, but also to use all the constraints that one can have from the observation, such as colors, such as the light variation, which are correlated in different bands, which we will have with Rubin LSST. Also the photometric quality parameters that the photometric codes allow to use, and also maybe straight looking at the images. Because this can be very useful to distinguish different classes of objects with similar light curves, that keeping in mind that for quite a long time we will not have for each individual source a lot of phase points. At the beginning, it will be very difficult to distinguish, for example, RRC type from binary stars in some cases, because sinusoidal light curves can be difficult to distinguish and periods can be difficult to find. And also we will have a lot of false detection associated with spike saturated stars, extended object, and all sorts of phenomena that can affect the data reduction. So this is the first point. The second is...
Matteo, you are at the 2 minutes mark.
Okay, already. Well,
yes,
so, okay, 15 seconds to say that I'm also interested in testing the outcome of different brokers to use this as input for variability search. And in the next slide, the only point I would like to stress is that I will have soon a postdoc to work on this related to this issue. So we will be happy to collaborate with any group.
Wonderful. Thank you so much. And the next one is me. I can catch up with some time. So this is just a very preliminary project. It is called Rubin Rhapsodies. It's a software that we want to build to automate the sonification of our Rubin data, particularly starting with light curves. So sonification is just the expression of data through sound, as opposed to the most common way to express data through visualizations. Why would we want to do that? There is a scientific throughput because our auditory apparatus, our ears, work differently than our eyes, so we can understand data patterns in a different way that is complementary to that which we can understand through visualizations. Of course, there is a motivation of science inclusion as well. This gives access to Rubin data to people who are visually impaired and cannot interpret data visually. Also, there is an aspect of public outreach. Sonifications are very often used as public outreach tool. The issue is that there is no unique scheme to transform data into sound. There are many features of the data that we want to represent and many features of the sound that we can tap on, but not all are good combinations. So the software development work would take first the approach of identifying what is the best mapping of properties of the Rubin data into sound elements, and then to automate the generation of the sound of the sonification of the Rubin data. And the particularly difficult hurdles are in the integration of this with the Rubin Science platform to make it accessible to all users. The stage of this is very preliminary. We have a small team that prototyped the idea. These are two students of mine. They presented their work at the Rubin PCW last summer. And we also submitted a Kickstarter program that connects universities in the Mid-Atlantic area, University of Delaware, Lincoln University, and the Rubin Sonification Workshop and Rubin to forward the plan and continue advancing this software concept. I believe this was the last presentation for the Lightcurves. So let's take 3 minutes for Q&A to any of our speakers. And perhaps let me stop screen sharing so that I can see if there are hands up or questions, or anybody wants to unmute and answer questions and ask questions.
I see Christopher's hand up.
Thank you.
Yes, hello. I hope you can all hear me okay.
Yep.
Matteo, you said your personal bias is towards pulsating periodic stars.
Yes.
But is the analysis, like, is the software you're thinking of meant to be also specific to like some periodic features similar to what Dragana is proposing, or do you want to do like generic light curve feature extraction with like any kind of model that you can throw at it?
I think that the general software will be desirable, and then, but being sure that anyone tests its own science case that is efficient with all sort of light curves features. But yes, I'm in favor of some general software as the one proposed by Dragana and Angelica.
Excellent, and perhaps it's worth emphasizing that as people propose software, particularly as in kind, we had discussions with the in kind teams that I think are valid also for software that is presented not as in kind. So that outline the fact that, of course, one wants to build a software that is consistent with their interest and domain expertise, and there is advantage in doing it that way, but that software should be built with the idea that even though it's addressing one specific need, it should be designed such that it can address broad needs of the science collaboration. So I think it's an asset that you have something in mind that will help you design the usability of the software, while also keeping in mind that you want to make it accessible for other uses. Does that make sense? Do you think that that is a reasonable expectation, Matteo, a reasonable goal?
Absolutely.
Excellent.
Fully agree.
Ken.
Well, I thought Christoph had his hand raised before me. So I was just going to ask, I'm going to turn my video on. What do you, this is for Matteo really, what do you envisage the brokers, in what way do you envisage the brokers helping you pull out information about periodic things versus, for example, the data releases? What were the brokers, the potential advantage for the brokers?
Yeah, what I have in mind at present is, for example, to select some known variables and look for these variables in the different blockers and see what happens. Mm-hmm. So see efficiency, see if they give the same classification. So it's this kind of experiment I haven't done so far, but I think it would be interesting to do. Probably is not one broker that will be the best, but I mean, the broker will be optimized for some specific case, or so it's not one information from one broker that will be the only one needed, but be a combination.
Yep.
Thank you. Let's move on to the next session. I'm going to share my slides again. Do you still see my slides? And let me quickly go through to the next session, which is on classification related software. And Robert Szabo is our first speaker.
Hi, everyone. Welcome. This is presented on behalf of the Hungarian in-kind contribution team. I think we can already jump into the second slide. So the idea is to provide a machine learning based classification of variable stars and to find and classify and maybe characterize the large amplitude variables. First of all, we presented here, listed here the main variable types. And the idea is to provide a periodically improved classification as LSST data pour in. And that, of course, this kind of software would be beneficial for various subgroups and even various science collaborations. There is no specific date to be ready with this, but that would be beneficial to have it ready by the start of the main survey, of course. So we have a team of 3 of us. We are sitting here, Attila Bodi with me and Tamás Klenar, but we are also open to merge with various groups or to have someone on board who is interested and could help us with the software development. We are not yet 100% sure about the platform that we should use, but we envisage the heavy use of GPU, so that's a need on our behalf. And the last slide will show that we already formed a team, and it is, I would say, it is close to funded, and we can start once we define what is required on our behalf. So if you are interested, please contact us. Thank you.
That's great. And this is an in-kind contribution that has been approved. So your first report to Rubin will be due this coming December.
Okay, thank you.
Right. So next on deck is Tim Naylor.
Sorry, I thought I was an expert one. Okay, and next slide then, please.
Yes.
So for those who don't know me, I'm Tim Naylor. I work in Exeter in the UK, and I work on young stars, radial velocity searches for exoplanets, astrostatistics, and I'm involved at the moment in delivering a couple of software projects. So significant efforts are going into light curve classification for LSST, but actually there's also significant legacy data which can help us identify what are the sorts of variables we're looking for. And I'm talking about big surveys like VISTA, WISE, and Gaia. So the question comes, how can you merge all that information into something useful as a classification tool? And a good way to do that, obviously, is to merge these surveys using some sort of machine learning. And in my own field of star formation, and there are a few examples around already, like Vioche et al. And Kuhn et al. And McBride et al. Who've done this on a smaller scale than we will be thinking of doing it now. And indeed, I have my own projects delivering catalogues calculating this way for Weave and probably for Foremost, but that's still under a proposal. And there are significant advantages if we can do this across all science areas, because of course, any classifier will benefit from having many more classes in it, rather than a class which is what I'm looking for and what I'm not looking for. So if I could have the next slide, Federica. So here's the plan for what we could do. The first thing we need is cross matches between Rubin and all those other catalogues. And that is in fact an agreed part of the UK in-kind contribution which I'm leading. Those cross-match catalogues will exist. Then we require groups of people who are interested, who are going to provide us with lists that can be training objects. So please, yeah, I'm very open here. Anybody who can come on board would be tremendous, because it will just make our classifier so much better if we have many more classes in it. We'll probably then need a scientific investigation phase. And at the very minimum, that will be to take the off-the-shelf packages that exist for machine learning and pick the best one, which could do it. We could also try bespoke software. Then we have to work out how we combine this with a light curve analysis to build a truly global classifier. Once we've done all that, we could build production code to do it. And then I suspect that there'd be at least one cycle of improvement of that against Rubin data. So the idea is that you would run this every year against each release of the Rubin data. And of course, in the end, we would need to document what we've got. Thank you.
Thank you, Tim. So next is Sara Bonito.
Yes, thank you. So next slide, please, Federica. Our idea for software is tuned on classification of variable stars, basing on young stellar objects, because our expertise, this presentation is on behalf of myself and Teresa Giannini, is on star-forming region young stars. Here's some information as required in the form of this slide. So the classification for stellar variability, also in the context of the Rubin Science platform, the relevant groups of TVS or other science collaborations that can be related to these are the non-degenerative variables and the classification group in TVS, but also in the context of galactic plane in the stars Milky Way local volume science collaboration. This has been proposed as a derectable in-kind contribution by the Italian National Institute for Astrophysics. The theme of the in-kind specific for the classification of variable stars based on young stellar objects has been defined in the in-kind project proposal, but of course external collaborators are welcome. And some specific skills are here listed. They are not limited to, but based on the analysis of the light curves and the color diagrams, and of course the use of Python inside the Rubin Science platform, but also out of these. So in the next slide, please, you can see what we have done about that. You can see in these two plots on the left, our results to populate properly a light curve to retrieve variability for accretion in this case. And you can see this in the cadence note we have recently submitted to the project. And on the right, our work for the to develop this software. You can see other names of the team here and the website. And this is an example of a light curve of 40 years. So with Rubin, we can explore both short scales, on the left, hours to days, and on the right, time scales of decades, in this case, the whole survey. We are at the prototyping idea, and the team is not yet funded at this stage. I will stop here. Thank you.
Thank you, Sara. Thank you very much. And this is the last for this section. So let me unshare and ask if there are any questions. While you think about it and think about raising your hand, I want to emphasize that it seems to me like there is a very significant overlap between cross-matching and classification, perhaps higher than I thought. So maybe tomorrow's breakout rooms, maybe they don't need to be separated. Maybe those two efforts really need to be talking to each other.
I know there's a comment in the chat from Michael.
Excellent. Large-scale machine learning catalog work is dominated by feature extraction with some labeling active learning work, at least for ZTF Atlas scale catalogs. So it seems that the machine learning catalog folks should be working very closely with the teams in the Lightcurves section, who sounds like they will also be producing these. Entirely agreed. Any other comments or questions on this?
I have a comment, if I may.
Please.
I'd be interested to hear from the broker team representatives, because at the last broker workshop, there was quite a breakout session on classifying variable stars and how the broker teams would actually like feedback from people who study variable stars on exactly what we're looking for and how to find them. So I noticed we have several representatives of the team here. Perhaps they'd like to comment on what the community can give you that would help.
So here at LASER, we've been trying to engage the variable star community with limited success so far. So what people are asking for, and what I've got the feeling, and it's partly the reason behind my question earlier in the session, is generally information about the periodicity of stars, really from a non-differenced catalog. So of course, if you have a difference image, you've basically got a baseline where you're starting from. So of course, we don't get a difference detection until we've got a 5 sigma detection above or below that baseline, and that baseline is defined by whatever template is chosen. So I've found that the variable star community, certainly the people I've been interacting with, have been less enthusiastic about trying to interact with what we currently have, I guess coming from ZTF, because we're trying to effectively reconstruct the periodicity of stars. So that's been my feeling so far. You know, and ultimately the question has always been, oh, I'll wait for the ZTF data release, or can I get the DR0 LSST release? I'll wait for that.
We certainly can facilitate discussions between LASIR and the variable stars community, which is largely embedded in the TVS.
Yeah.
If there are no other questions, in the interest of time, we're going to move on to the next section. Goes in 3, 2, 1. Here you go. Cross-matching and related software. And the first group to speak is Michael and Igor.
All right, can you hear me?
Yes.
Okay, you can go to the next slide. Okay, so Igor and I and many others in this call are interested in multi-messenger stuff in general. Of course, to do multi-messenger astronomy, it means that you have knowledge of cross matches to a variety of facilities, IceCube, Fermi, LIGO, Virgo, etc. And so there's a lot of work to be done to basically filter the alert stream with knowledge of for example, the sky maps and the data products that are being produced by these facilities. This is closely tied, in addition to the Lightcurve classification inference work, where, for example, you're producing models fit to Lightcurves based on knowledge of the data products that are coming from LIGO and Virgo, say, you know, the time of explosion or the ejecta quantities put out by the collaborations and so on. And so we are doing a lot of this work for ZTF. I know Ken's doing a lot of this work for Atlas and Pan-STARRS, so I know a lot of it's happening in the community, but I think it's very important to flag for this crowd that someone has to do it for Rubin. My expectation is that for Igor and I, we're doing it for ZTF, and we are at least thinking about it in the context of Sky Portal, which is, you know, let's say a prospective code base for doing a lot of this work for LSST as well. But I would say overall, there's a need for folks in the community to take this up. You know, this is not an in-kind contribution of any kind, since I'm at a US institution, but it's more just a flag that I think it's important that folks think about this if you're interested in doing MMA with Rubin. Thanks.
Thank you so much. Michael, you muted yourself. I assume that you did that because you were done.
Right, with 10 seconds left. I had a time.
Thank you. So next is Tim again.
Hello again. Can I have the next slide then, please?
Yes.
Okay, so I talked about cross-matching earlier, and cross-matching at Rubin depths is a problem. A lot of science depends on it, but the number that hit me square between the eyes when I first came across this problem is if you draw a classic 1 arcsecond radius cross-match with Rubin, it's not going to work. And the reason it's not going to work is if you look in the galactic plane, that for example, L is 50 and B is 5, so I'm not really in the guts of the plane, then you will have a random star in 1 in 4 error circles in a single visit, okay, which will give you a 1 in 4 mismatch, which is completely unacceptable. So you have to go about it in a different way with Rubin. And basically you've got to use those centroiding uncertainties that come out from the image analysis. And it's best probably to fit that within a Bayesian analysis. And the granddaddy of all the papers that do this really is Sutherland and Saunders in 1992. But the problem here is that if you just go in and use those sort of centroiding uncertainties naively, you will underestimate the uncertainties due to 2 problems. First is proper motion, that your catalog you're matching against might be 10 years old. And the second is crowding, which is within your PSF, you will have undetected other stars, which will pull your centroid away from where you think it should be. So if I have the next slide. So you can use a variety of techniques to overcome these problems. And Tom Wilson, who's the programmer and software engineer who works on this stuff, and statistician indeed, and I've produced a series of papers where we've addressed the ways of doing that. And what we've done is, the idea is here that we write software that will run on the UK DAC after each data release and do the cross-matching for us. And that's already been accepted as an in-kind contribution from the UK. And as I say, the developer on that is Tom Wilson. And in fact, I think as TVS, one of the biggest decisions we have to make now is which catalogs we want to be cross-matched against. But to be clear, all this was proposed about 4 years ago when Rubin was going to be on a different timeline. So we're going to deliver the software. And the question is, well, then what? And so what I'm proposing as a further in-kind contribution is, first of all, that we have the staff effort to actually run the software. And then there are two other things that we could think about. One is to do a super match, which is not only to cross-match Rubin separately with each of the catalogs, but ask the statistical question, what's the best match across all the catalogs? Can we have the complete SED, please? And the other thing is, where we have more than 2 epochs prior to Rubin, we can look for very high proper motion objects, which will have shifted significantly, which you need 3 epochs to actually prove are the cross matches. Thank you.
Brilliant, thank you so much. These were the 2 cross-matching sections. So let me see about questions. Tom? Hello, Tom.
Hey, Fed. So I have comments about the MMA cross-match. And I think, I don't want to speak for the other broker teams, but I think that they can chime in, but I think they'd agree with me that this kind of cross-matching for the MMA targets is really important from a broker perspective, because this is something we need to do fast. And so all of us have been thinking about ways to do this. We have various techniques that we've tried to deploy, but I think that this is an area where certainly all the broker teams would be very happy to hear input from people who've developed tools to do this. And we'd be happy to work with people to try to implement different algorithms that they've developed to try to improve this. Because I think that this is one of the places where the brokers really help. They are at that front line looking at all the alerts coming in, and being able to do this kind of cross-match is really important. So I'd be very happy to talk to people about how they want to work with that. And certainly I'm sure all the other broker teams have a similar view about that.
Thank you, Tom. And in fact, let me actually, before I give the microphone to Massimo, let me call Troy Rien, who's representing the Google Pit broker, because I saw you turning on your camera now and before as well, and I didn't give you the word earlier.
Thank you. Yeah, I'll just say, so I'm working on the Pit Google broker. We're very much in development. We don't have anybody in-house who is developing classifiers. We are implementing community developed classifiers. And so and we are very interested in collaborating with any of you who are interested in putting one of these classifiers, or I'm sort of calling them all classifiers, but I'm referring to all 4, obviously, of the categories that you've got here. So we're very interested in collaborating. Anybody who wants to put one of these into the live stream. I'm personally very interested in variable stars, although I haven't had much of a chance to work on it. So all the stuff that you guys are saying here today is exciting to me.
Brilliant. And one last question or comment from Massimo?
Yeah, it was just a quick comment. I strongly suggest the Teams point, because today we had a huge problem with cross-matching catalogs with different resolution in a very crowded area, which is the Barnard Galaxy NGC 6822, and the classical match was just not working. So thank you, Tim.
Awesome. Yes, I was struck by your comments about how hard it's going to be. Not that I never thought about it, but I never thought about it deeply. So yes, indeed. Thank you. Let's move on to the last group set of presentations. A heads up to everybody that we are just a couple of minutes late. And I want to say, in the background, I will organize together with the task force for software. I will organize the breakout rooms for tomorrow, but keep in mind that tomorrow we'll run this on GatherTown. So the breakout room are just areas where you should be able to find your favorite developers and talk to them, but you will be able to move around and talk to a number of teams. Although we will ask that every room shares a few words at the end to tell us what the discussion was about. So people that are in the room, and particularly developers, think about that as you go through the 1 hour tomorrow. With that, let me share. Let me put it in presentation mode and go to the next slide, which is Lovro for TVS Dash.
Hi, thanks for the introduction. So we heard a couple of very interesting and nice ideas about light curve analysis and cross-matching. And the TVS dashboard would be an intuitive and interactive. Can you just move to the next slide, please? An intuitive and interactive tool for first look online graphical analysis of light curves. It would be running on a Rubin Science platform, and it would be customizable in the sense that you could tune the graphical user interface to your science case. It would also be modular, meaning that new packages could be added into the GUI as they are developed, and it would allow basic visualization, the results of various metrics, query results, algorithms, and so on, and the general analysis of your light curves, along with the access to various analysis tools co-developed by the TVS. It would also be integrated with other Rubin analysis T tools, and it will provide access to databases, various methods, cross-matches, and so on. And I think this would be useful to many other science collaborations, pretty much all the science collaborations that have anything to do with the light curves or light curve analysis. Next slide, please. Okay, so this idea is not a part of the in-kind contribution, as our contribution is directable and basically just provides a software development effort. We do already have one postdoc hired that is supposed to do the software developing, so this would be a very good project for her to work on. Because basically we have in-house experience on the light curve analysis, and we would be very happy to aid the community by developing this, what we think is very useful graphical software. In addition to the postdoc, we have that's going to work on the software development. We also have additional 2 postdocs and a PhD that could spend some time on the development, but we foresee that some collaboration with the external developers would be necessary because this is a rather large project. Skills that are needed would be Python, database access skills, user interface, and understanding of the Rubin Science platform. And if this proves to be popular, certainly an API or even a full-fledged Python package could be developed in case somebody prefers, or if in case that there are enough users that would prefer a programmatic approach to GUI. So the questions that still need to be answered is how would the resource management work on the Rubin end? So how much cores, how much memory, and how much disk would be accessible to a single user? And one of the ideas would be to offload this to one of the IDACs. And I see this as a general step towards TVS portal that I think Yanis was mentioning in one of the previous telecons, where we would find an integrated environment for everything that's TVS related. Thank you very much.
Thank you, Lover. And speaking of Yanis, Yanis and Marcus are up next.
Thanks, Fed. Okay, so this is about our in-kind contribution, which was approved. It's directable. So there's a significant overlap. I didn't realize there was such significant overlap with what Laura was suggesting. If you move to the next slide, you'll see what I mean. Okay, so our goal is to develop a TVS target and observation management system. So this is a kind of an all-purpose system where you can use to use your science. So it's relevant to all TVS subgroups. It will have an online interface that is customizable to your project. As I said, it is a directable in-kind contribution. And we would like to have an alpha version deployable by the start of operations. Our core team is basically myself and Markus Hundermark. We have developed similar systems in the past, but contributions are, of course, most welcome. Then the software, we plan to develop it primarily in a Python Django framework. What we want to do, if you move on to the next slide, yeah, we want to deploy some demo projects. So we'll be contacted, some of you, or you can contact us. We want some sample projects. Okay, we want to develop this system to show what it can do for specific projects, and then we can show it to the rest of the community. How is that useful? Okay, so the first steps will be to work with you to create demo TOM systems. A design that is based on, if any of you have used, for example, TOM toolkits before, for example, like the ZTF or the LCO toolkits, something like that. So these will be self-contained modular projects. You can include different parts, like if you want to view Lightcurves, if you want to fit models, you can call your favorite, fitter. Some other people are developing fitters, so you can call that, get the results back, and so on. So they can be copied, modified, and deployed elsewhere. It should be designed flexibly enough to incorporate ideas in new modules. And the second thing that we want to do is to create a user database to help with TVS subgroup and task code management. Okay, so you can see a sort of data flow diagram on the right, very simple one. You get the photometry, the alert stream, the brokers goes to the brokers, and then you as a user will select the things that you're interested in, the objects, and put them in the database. So at any point, you'll have all your targets, view them and do things with them. I think I'm past my mark, Fed.
Thank you, Yanis. Next up is Massimo, Precision PSF Photometry, very crowded environment.
Yeah, thank you. Probably I'm in the wrong section, but it was my fault. As you can see, it is a complete full processing pipeline from the PSF modeling to the Lightcurve. Next slide, please. And we don't have a name for this yet, but the idea is to perform PSF or frame photometry on very crowded regions, extraction on the candidate variables, and then computing periods and mean quantities, and maybe a classification. And I think that proposed software covers area which are of most of interest of all the subgroups and science collaboration agencies, mainly TVS and STARS Milky Way local volume. It is part of the Italian INAF Institute in-kind contribution, and this is directable. And should be in a good working condition by the beginning of the survey. We have a strong experience on this field, but of course, fresh ideas and skills are more than welcome. So we are planning some synergies, for example, with other groups, for example, with Matteo, and also we discussed at this point with Sara, and specific skills are under consideration. And we plan to perform the first part of our pipeline on local servers, because this is strongly resource consuming. This means that we need local facilities, maybe linked with to the Rubin Science platform, while the rest of the pipeline could be run on directly on the Rubin Science platform. And in the next slide, please. We already have a first version of which is unreleased of our pipeline. Here you can see some result based on the reduction that we performed within the crowded field task force, and we made a full automatic PSF photometry, semi-automatic search for variable stars and Lightcurve generation. Of course, we are looking for more variability criteria and looking for specialized algorithms for different variable stars types. I think that, and we are, I think, in the middle of point 1 and point 2. So we are going to finalize our efforts on this. Thank you.
Thank you, Massimo. And the last one is actually my my presentation on something that is entirely just an idea. I'm actually not working on it at all as of now. It haunts my dreams though. It is the machine learning portion of the TVS portal. What I would like to see is the construction of a, let me make sure that this doesn't start playing with sound. The construction of a machine learning portal that enables machine learning analysis through a GUI. And that as it does so, it provides recommendations to the user about the choices that one has to make when doing machine learning analysis on data. So if you look on the flowchart on the right, if you look on the example on the left, this is just an existing example of one machine learning model dashboard. If you look at the flowchart on the right, the idea would be that this will be an interface that allows you to, helps you selecting the data, selecting the features and extracting or engineering the features from the data, identifying what is the task that you want to do, whether it's classification or regression, because at the end of the day, those are the two machine learning tasks. And based on this, recommends analysis for you, helps you pre-process the data in the appropriate way, runs the pre-processing, helps you define the hyperparameter, the loss function, the cross-validation scheme for your models, runs your model, evaluates the model by standard metrics such as precision, recall, etc., and even helps you interpret the model by running an automated feature importance analysis. So I don't think this should be a standalone software, but I think this should be something that the people that are considering building the TVS portal and the TVS Dash would want to include as part of their analysis. And I will be happy to work with people on this, although this won't be my primary activity over the next several years. And it's not an in-kind contribution. It's not, there's no team. It's just something that I think we need and will be beneficial to TVS. And with that, we are at the top of the hour. And so I want to acknowledge that if anybody needs to leave, that is absolutely fine. But I would also like for those who can stay to spend a couple more minutes on questions, if there are any questions. And I see Massimo's hand up.
Sorry, just a quick communication. I forgot to mention that unfortunately tomorrow I will not able to join the discussion because I will be traveling. So anybody interested or curious can chat with me by email on Slack. I will write my email address in the chat. Thank you.
Excellent, thank you. Rachel and then Yanis?
While people are designing software and while we have everybody in the same room, I just wanted to put in a comment on the design of software, especially some of the ones that we've heard about that could be applications that can work synergistically with other software. Please design them as APIs so that they plug in easily to other portals and software, and that allows the maximum flexibility in where they can be implemented and used.
Thank you, Rachel. Yanis?
Just a quick question for Massimo. It's only going to do PSF fitting photometry, right? Is there a reason why you selected PSF fitting photometry as opposed to difference imaging, optimized difference imaging photometry in this project?
Yeah, this is an excellent question. Basically, the idea was not, the PSF photometry was not intended for variable stars, but for static science. And with the frame, you can get a better precision and accuracy. And the light curves are the byproduct of this process.
Okay, thanks.
Thank you.
Right, my understanding is that the difference image analysis that Rubin promises to deliver should take care of crowdedness, even in extremely crowded fields, for variable objects. Although there are a lot of people that are working actively on that difference image analysis. So that also perhaps is an effort that people with expertise could join. Any other questions or comments? Hearing none. What's going to happen is, oh, Christoph.
Sorry, I just want to say I'm hearing light curve fitting as a component in many of these projects. And I admit I'm a bit lost where these are complementary or where they could be merged. I guess that's it's a question to Michael, Igor, and yeah, everyone else who has presented stuff about that.
And I see that Yanis has raised his hand perhaps to answer, but I just want to emphasize that's great because that exactly sets the stage for what we want to do tomorrow, which is understanding the overlap, the interplay, the collaborations that might arise to solve these problems, understanding what software needs are interconnected, and what solutions are provided by different pieces of software. Yanis?
So yeah, I mean, it depends exactly what we want to fit, and each of us has different areas of expertise in the kinds of science that we want to do. For example, microlensing events are particularly complex. They take a long time to fit. You know, maybe if you have an RRA B star, it's a bit easier to fit. It doesn't take so long. So the way that I see it is everybody's going to work with each other and develop their own fitting algorithms, but they have to be modular, okay? And then we can all access them. And then we find like interesting objects, and then, okay, we can use this algorithm or even different algorithms that can fit different objects and compare the results. That's the way that I see it.
So what's going to happen now is that in the background myself, asking for the help of every member of the TVS Software Task Force, we'll prepare a map of GatherTown with groups where the people that have proposed software should hang out in small groups or individually, so that the audience can visit them tomorrow and continue these conversations. So stay tuned for on the Google Doc to check out the map of the GatherTown environments, where you will see where you can find the people that you want to talk to, and come promptly to the GatherTown link tomorrow at 11 a.m. Eastern. Not going to try and provide conversion to other time zones because it always goes wrong when I try. So 11 a.m. Eastern for 1 hour of conversation, or rather 45 minutes of conversation and 15 minutes of wrap up. I'll see you tomorrow. Ken.
Just one question. Where will the slides for today's session be? Will there be a link on the
yes, I'm going to post the slides on Slack and on the TVS channel. I'm going to post the video on Slack on the TVS channel. Angelica, actually, I wanted to ask you, we weren't able to start the recording right away because I didn't check that I was the host of the meeting. Can I ask you to meet briefly with me at some point to run over your presentation again and record it, or record it by yourself on Zoom somehow and just hand it over so I can collate it to the existing slide, to the existing presentations video?
Same goes for your starting presentation, Fed.
What is it?
Same goes for your starting presentation.
Yeah, I'm planning on re-recording that as well, yes. Angelica?
Yes, that is fine. I will record it by myself and send it to you. Thank you.
Excellent. Just send it to me on Slack and I will collate. And Rachel, you are the host, so you have the main video. So I'll connect with you to edit.
Yes, perhaps it makes sense if both of you send your videos to me, because the longer video will be this one.
Yeah, exactly. No. I don't want to ask you to do that though if you don't have time. I can make time.
It shouldn't take too long. I have the kit. So
awesome. Thanks everybody. I will see you tomorrow. And especially thank to the brokers representatives that came along.